Yeah, so you create new project, console, see, you name your project, whatever name you want to give it. So yes, use this compiler. So the first version that we sent the setup, it didn't come with the GCC compiler. And we will talk about compilers in a bit, but it didn't come with the GCC compiler. So when you run code, you can't, it won't compile. So it won't work. So the last version that was sent, the link, if you install that one, then uh, you have the compiler in the directory, then you can compile your code. So this is the compiler. So finish. So we go here. So this is what we'll be programming in. So you can see um there's already a program here. So we'll talk a little about the program that's here before we dive into into each part. Yes. Okay. Okay. So um so the compiler we're going to use the GNU GCC compiler. And the IDE we're using is code blocks. I think this is the IDE you'll be using in in next semester for C programming. So it will be best if you just familiarize yourself with it. Yeah, because this is what you also be using in class. Yeah, so for the next 4 weeks, we will be for the next 4 weeks, we'll be in this ID and we'll be coding in C. Yes. So um it's also important to know the version of C you are running. I checked earlier, the version of C you are running is I think C17, I think the 2017 version, because not the version of C, but the version of our compiler. Because there are some things that maybe you can write, but then if the version of your compiler is different, it will not run. So it's also important to know the version. As we move along, maybe when we learn about preprocessors, then we can code up. how you can check for your version. But I'm sure you're using the C17 version of C. So C is a high level language. Well, now it can be considered as a low level language because of higher level languages like Python and JavaScript. I'm saying it's a low level language because it's the level of abstractions compared to Python and JavaScript is less. So um, when you write C code, your source code, it is compiled. Then so the process compilation is changing your C code into machine code, zeros and ones that are understood that can be run directly in your CPU. So the difference between languages like C and higher level languages like Python is um, basically no the level of abstraction and uh, how it's changed to machine code. So Python and JavaScript, and I think Go, no, not Go, Ruby and other languages are um okay, they are compiled, they are interpreted. So JavaScript and Python are interpreted languages. C, Rust, I think Go are compiled languages. So a compiled language, you write your source code like how we have here right now. Then it will change the your compiler will change that whole code into machine code and save it in an executable file and then run it. So you can see here when I run the code, you can see here the name of how I saved the file. It was saved in an executable file and it was run directly on the CPU. So this makes C code very fast because from C code you go to the compiler changes to machine code and runs directly on your compiler. Whilst for languages like Python and JavaScript, it's interpreted line by line. So for each line or a chunk of lines, it's changed to machine code. So like how someone interprets in a different language, right? Line by line, no line by line. By compiled languages, like it changes the whole source code into machine code and runs it. So it makes C code faster. And C was used to build Python, right? So it's like the levels of abstraction, right? So from C code, it gets reduced to machine code, and then machine code is understood by your computer and it runs. But from Python, then it gets changed to bytecode, and then in bytecode before it gets changed to machine code before it runs. So because of the levels of abstraction, C is relatively faster than Python. And C is can also be termed usually termed bare metal because it's closer to your computer system than higher level programming languages like Python. Yeah, so we'll be more concerned with stuff like memory allocation and going a bit low level and understanding binary and bytes, stuff like that, because we are at a lower level language as compared to Python. Yes. So let's just get straight into the code. So this is, I'm sure most of you have this. Like when you created a new file, you saw this. So let me just explain what you are seeing right now, each part. So I think it's very different from what you are used to with Python. Then we'll go through this, but then we'll start with the foundations. Okay. So this is pre-processing. This is a preprocessor. They includes a preprocessor, and this is a header file, a header file. The if you see .h like this, it's a header file. And then coming down, we have int main. This is where we write most of our code at. It's a function. And this is where we write most of our code at. So when we progress and we start doing functions in C, we'll be writing our functions outside of this main function because this is a function in itself, which we write most of our code in. But as we write other functions, we write it outside of the main function. But most of our code will be written in this function. So let's go back to the preprocessor part. So the compilation, C compilation is in two parts. So you have the main compilation and we have the preprocessing. So this is the preprocessing step. So basically what this does is like an import in C. So you are basically dumping your file in this environment you're in right now. You are dumping this file in it. And these two libraries are very important libraries. And for almost every C program you see these two libraries above it because they contain the basic functions that we use in writing our programs. So this is a standard input output header file. So it's a file that contains some of our basic input and output functions, like as we will get to know. But you can see here right now, printf, which will output hello world into our output stream. Yes, so this basically saying bring standard input output header file into my file here right now so that I can use the functions inside. I can use the stuff inside. The same for this. This is a standard library header file. So it's like hashtag include um this header file. Like bring the file into this file so that I can use all the code or all the functions in that code here without getting an error. So when we start doing with multi-file projects, which we hope to do if we can move at speed, you will see something like include maybe um helper helper files, something like this. I think usually come. So you get to see something like this. If you are writing your own code, maybe you write some functions in a file, multi-file projects. You write some functions in a file, and you want to use maybe those functions or that code in that file in this file. So it's like import that file into this file. So for that one, you use quotation marks like this. But these are the standard libraries. So for standard libraries, there are a group of standard libraries. So you can see some of the header files that are standard that you can use. A couple of them are here, and those go in these brackets. But then for your own files that you want to maybe import on the function to this file, you use quotation marks like this. We'll go more into that as we move on. As we do multi-file projects. Yeah, I I hope that everyone has maybe a small book that you can be writing some of these things down. If I'm moving too fast, you can someone else in the chat. It's compiling the same as building. Um, I, I don't know what you mean by building, but compiling is basically changing your high level code that human beings can understand to your source code, what we are about to learn, changing that into zeros and ones, machine code, so that it can be run on your computer to execute whatever function. Yes. Where was I? Yeah, so I think we are good with this. Let me just talk about one other preprocessor, and then we'll continue. So there's this define in. So maybe if you want a constant, you want to write down a constant, maybe n, you're going to use it in your code somewhere. You can use define n 100. So yeah, so they just had a define n. So n is 100. The value of n is 100. It's like assigning 100 to n up there. Yeah. So I don't think we can do away with this. Um, only need these two for now. Yeah, so let's get into the main function. Yeah, so for functions, we'll get to know them how they look like in C. I think Python, you just write the name of the function and then uh, a colon after it and write a code. Or your function, the argument and a colon, then write a code below it. But for C, you have to first write the data type. What is your function need to output, right? So yeah, int intuitively means integer. Main. So this is where I most for code at. This is like um the standard. Like this is how all C program is. Yeah. So print f hello world and you return 0. Without a zero, the program will still run, but you have to usually use best convention to put the return 0 there. And because you are returning 0, that's why yeah, it's defined as an integer function. They don't really they don't really matter like that. Yeah. So yeah, so when you write your code like this, then you can use this build and run. Okay, I've seen what the guy was talking about. Yeah, so yeah, so I think the same thing. Compiling your code, building your code. So you can use yeah, so you run your code, you build and run your code. Uh, Come let me clear this. I don't so don't open it. Yeah, so let's just run it. Then we'll go through how this happened. Then before we start going into writing our own code. Yeah, so it prints out hello world. So what happened was that so first of all, it pre-processed this and it dumped our header files into the file you're working it. So now so you can just make a quick Google search. And what are the standard inputs? What are some of the functions in standard input and output header file? What are some of the functions in standard library header files? Um, as you move, you see them, but you can just a quick Google search to see some of them. So printf, scanf, gets char, those functions are all in the standard input output header file. So functions that are going to input to your um functions that are going to input into your output stream, and then functions that are going to that will collect data or whatever you input from your input stream. So those are the functions in your standard input output header file. So it just dumps all those functions in here. So without if you don't bring this part, it's not the compiler is not going to pre-process it. And then that means in your code right now, there's no printf function there. So this won't make any sense to the compiler. Yes. So it pre-processes these, dumps the contents of their file here, and then it just performs this function, right? Printf. So this is the syntax for printf. So you just need to know this. And all C code ends with a semicolon. A semicolon. As you get to code more, you get familiar with it. So now you do a printf, you return it. So you compile the code, it changes it to the um zeros and ones machine code. That's the compiling process. And then it runs, the machine code is saved in an executable file and it runs. And then it's executed in so you can see the result in a console. This is I think a shell, a console. The by it was a bit slow because it's code blocks uses a CB console runner to run your your code so that it can be displayed here. But and that process is very slow. I don't know that it's very slow on your computer, but it's very slow on mine. So what I usually do is what I usually do is that I just run it directly here in command prompt. So I just go to the directory where my code will be at, and then I run it. Okay, I'm coming. So so you go to the directory where your code ran at. If yours is also slow, like you can do the same thing. So command prompt, you open command prompt, get a directory of where your code ran at. So you just build with Control plus F9 for Windows. Then you just run your code here. So that's what I would be doing. So yeah, so that's what I would be doing. Yeah, but then you can just use this build and run. Yeah, you can just build, click this button, then your code will run. If there are any errors, the logs will be here, and then your code will run in a window like this. Yes. Is if you have tried this and you're successful, that's nice. If you have any problems, you can raise your hand so that I'll check. So you can unmute and talk. Uh, okay, so yeah, let's continue. So I think now we are okay on the concept of compiling and C programming. So why are we learning C programming as electrical and electronics engineering students? Um, First of all, C programming, helps you. You need programming. You program software, algorithms, instructions to automate stuff and to do stuff for you. Um, C is fast, so you can do that faster because it's closer to the bare metal. Also embedded systems. As electronics engineers, you be dealing with microcontrollers, um, stuff like that, and they are usually programmed in C. So C is the, I think, most popular high value language to in embedded. If you want to go into embedded systems, you need to be good in C. A good in memory, the concept of memory allocation, uh, yeah, stuff like that. So you need to like learn C. Yeah, basically. So yeah, let's start with the foundation. So let me scrap this out. You already you've learned about uh, pre-processing, right? And these pre-processes. And then you learned a bit about header files, right? Header files. They contain functions, so you include them in this code. This is just English, right? Include this, so it includes the contents dumps it here, so you can use the functions in them. Yes. So the first thing I'm going to talk about uh, are variables. Variables. So basically, when you're writing code, it's best practice that you store stuff that will change or constants. Sorry, no constants uh, in variables, so that you can just call out those. You guys have done Python, so I know you know the significance of variables and storing maybe numbers or characters in variables. So that if maybe, for example, you want to change that number, you just change it at one section, right? Because, yeah, you just change that one section. So it makes debugging easy. It makes changing your code easy. And it's just good practice to do that. So, so a variable in Python, you just give whatever name onto the variable and assign it to whatever you want, whatever data type you want. But in C, you need to tell the compiler um what you're assigning to it. So whether it's an integer, whether it's um a decimal value, whether it's a character, a string. Basically, those are the data types we have, right? Numbers and characters. So you need to tell the compiler that, yo, this name is for a number. This name is for a character. This name is for a string. So you have to attach that to the name. So, for example, if you want to save an integer, the number 100, you can just go int number, your assignment operator, and your semicolon. So your C programs, most of them end with semi, all of them end with a semicolon like this. So basically, what you are doing here is that you are saying this variable name, we are assigning it to 100. Okay, that's fine. But compile, this variable name is for an integer. So then it will allocate the space on your memory for an integer. Do you get it? So you see already we are thinking about space and memory and stuff like that in C. We're not really doing that in Python. So you are saying that they allocate this number um to for an integer. So in C for integers, it allocates 4 bytes in memory to it. So 4 bytes of memory is going to number. And yeah, I think the compiler to save those 4 bytes for number. So this is how you assign a number. So for a character, so assign a character, maybe this what name should we get? Letter is equal to then colon, sorry, single quotation, with D, then a semicolon. No, don't forget your semicolons. Don't forget your semicolons. This is how for a character. So each character is 1 byte in memory. Just 1 byte. So when you do this, you are basically saying um give letter 1 byte in memory so that you can store D there. But a string it can go like this. Maybe um letters maybe 23 and then letters yeah. Don't never forget your semicolons, okay? Yeah, so for this one, this is a character. So a character is like an array in C, an array of character. A string is like an array of characters in C. So we are giving 23 bytes to a character. So if it's more than 23 um characters, it will crash because you have only allocated 23 bytes here, 23 bytes of memory to letters. Okay. Or you can write it in like this. But I prefer you write it like this. But you can also write it like this. You see here, you've not defined the space that you have given to characters. You have not defined the number of bytes you have given to character you have given to your string in like this. So there can be memory leakage. And yeah. So I prefer you use this. We'll talk more about this pointers arrays in a separate class. And then here to the preprocessors, we'll talk more about them in a separate class just for preprocessors. I just want us to get familiar with coding in C. Then we'll go deeper into the various topics. So there are various preprocessors that you can use. Not just include, I mentioned include and define. There are other preprocessors and there are how you can play around them. It will be nice. Yes. And then in a later class we'll talk more about this. But right now we're talking about data types, and basically our data, whatever data we have, are just numbers and characters and a group of characters which are the strings. So also we have for a decimal values, you can use a float. So float decimal maybe goes 3.14. It's 1.4, okay. And then you can also use a double like this. So this double is the data type for, okay, so float is a decimal values, right? The numbers with points and yeah, like that. So that's a float. A double is just a float, but with more precision. So if a float can go, your double is like twice of the precision of a float. So it depends on your sometimes the device and some of these things change and it depends on the compiler success and stuff like that. But then usually if maybe this can go four 4 decimal places, then this one can go 8 decimal places. Because like this one is allocated more, the compiler allocates more memory to a double than a float. So if in your whatever you are doing, you feel that you would need more precision, then you can use a double, but then if not, you can just use a float. Yeah, they're basically the same thing. Okay. And then this is for a number, a number. I can't really see anything much more about that one. And then a character. Okay, so I didn't give an example here. So for an example would be um maybe so this goes in double quotation and then hello. All right. Okay. So yeah, I think that's nice. That's nice. So you can see here that we allocated 23 bytes of memory to letters, but we only use how many? Just five bytes. Uh, yeah, okay. Let's see. You only use 5 bytes. Okay, 5 bytes. But in actual fact, I think it's six. It's six bytes because there's a hidden character. We'll talk about that one when we go deeper into the language. Okay, so I think our family is only 5 bytes here. We are familiar with data types now. Yes, I think basically this is what you need to know. So there will be a separate class on types, because then there are more data types when you're doing embedded systems. Maybe for example, you can add something like type qualifiers like constant. So it's like I tell the compiler, this number is very important to me, and I don't want it to change. So you add that. You get it. And then there are other type qualifiers like long. Long is basically telling the compiler that my number is going to be very huge to allocate more memory to it. And then there's the range of numbers that a long int can go and a long int can go. We'll talk more about that in a separate class. We just want to get familiar with coding in C first. Okay. I get familiar with your IDE as well. So int, float, double, and these. Okay. That is that's nice. So okay, there are some variable names that are not allowed in C. There's some variable names that are not allowed in C. So this is the slide I think we used last semester, last 2 semesters. I think you'll be using the same thing. So probably put this into send this into the Google Classroom so that you can access it. But then the variable, I think I've explained most of this stuff already. Uh, I want to look at, so you can see you have long unsigned and signed, long, short, long. These are they are size qualifiers and sign qualifiers. So sign means it can be positive or negative unsigned. Um, the number can only be positive. So there'll be a separate class where we'll discuss types and types qualifiers. There are like a lot of them. Then there'll be a separate class for that one. So let's not worry about that. Let's just stick to our int, float, double, character. Yes. So in naming variables, there are some rules for those. I'm trying to okay, yeah. So rules for writing identifiers. Uh, so a valid identifier can have letters, both uppercase and lowercase, digits and underscores. The first letter of an identifier should be either a letter or an underscore. You cannot have two underscores starting an identifier's name. You can choose any name for an identifier, excluding keywords. So the keywords are stuff like can't have a this is a keyword. It is the ones that usually are highlighted in your ID are keywords. And you can't use that to name your um identifier or your variables, which is like obvious because you don't want to confuse your compiler. Yeah, yeah. Uh, yes. So these are some rules. We'll put it in there. We can look at them and see the rules. Um, yeah. On how you can name your identifiers. I think you guys are familiar with the same in Python, so I think that is fine. So I think that's what we have for data types today. I think that's okay. for data types. That's clean. So let's move on to so we've done how you can name and identify your variables. The basic type that we have, I said we'll go more into that in another class. Now we'll move on to operators. Move on to operators. So the basic operations that you know, plus is written as plus, minus is written as minus, division is written like this, and multiplication is the asterisk. Yeah. So you have a list of operators. Let me go to the slides. List of operators. Yeah, so you have your. I think I made a mistake with on the. That's why I didn't highlight. I don't. It's not even. So this is a division. Okay. So plus, minus, multiplication, division, modulo. Like these are common with Python and most programming languages. So we just continue. Yeah. Um, and then our increment and decrement operators. Okay, so let me talk a little bit about increment and decrement operators. Then we'll have an example. So we can have I plus plus and A plus plus. So I plus plus is like um I plus plus is like you have your I, just add one more. It's the same in Python. So you guys are familiar with this. But then we have sometimes the increment is preceding it. You can have I plus plus or plus plus I. So basically what this like that it does your operation before it does the addition. And this one does the addition before it does the operation. We'll try an example if you do some standard input output functions, then we'll try and see the behavior of that. They usually they come in the exams, you know, like to know the flow of it, which one comes first. Yeah. So you look more into that. So you have assignment operators that you are familiar with it. It's like a combination of your unary operators, your arithmetic operators, and your assignment, your equal sign. So just combining them, right? And then you have relational operators. So relational operators are equal to, greater than, less than, not equal to, greater than, or equal to, less than. These are their symbols. You can just look at them. I think you are familiar with these already. So you can, if the relation is true, it returns one. If it's false, it returns zero. So take note of this. True is one, zero is false. You have logical operators. So the logical operators you have and or not. This one too, I know you guys are familiar with it. If you aren't, if you want me to go deeper into any of them, you can put it in the chat, and I'm sure you guys are familiar with these operators. Uh, yeah. So there are some examples here. Let's try them. So um, uh, okay. So is okay. They didn't. Okay, can't try this. So they've not defined EMB, so we can't try this. So bitwise operators, we'll deal with them later on. We'll deal with them. By the end of this tutorial section, you guys will be like really comfortable with C. We are going to go into most things. That will make you comfortable to just learn anything or any topic deeper on your own. So that is for operators. We just went through them. So we went through the logical operators, the relational operators, assignment operators, increment and decrement operators, and um yeah, your arithmetic operators. So let's get back to our idea. We want to be doing most of our work here. We need to get familiar with most of the syntax before we need to get familiar with most of the syntax. Then we can stay here and be writing our code. Yeah. Okay. So yeah, I think that's it for variable naming, variable types, and operators. So I just want to start coding and doing stuff, and we just get familiar as we continue. Yeah. So let's just start with uh, let us go into the data inputs and outputs. So the data inputs and data input is basically okay. Data output is like you just want to output a string or a number or the data types into your output stream. So when you do that, it will be able to come out here. When I run the code, it will come out in my command prompt. That's your it goes to the output stream. And then for data inputs, it's like they are taking anything from the input stream. And the input stream is whatever the user inputs into the computer, right? That's the input stream. And then function that take data from the input stream and manipulate it are data inputs, data input functions, and then data output functions like print in C, output whatever you put in, whatever data type you put in. So print function in C goes like this. Print F. In Python, I just see it just prints. Yes, it's print F. And you can just print F anything. Right? Hello world. And then no, don't forget to add your semicolon. Don't forget to add your semicolon. Yeah, so let's run that. Let's see what I need to run. Yeah, so you printed hello world. So you see, I said earlier that the return zero doesn't really matter, but it's just nice. It's just best to just put the return zero after I run the code. Yes. So and then let's do some more. So let's name put name there, right? Name. And let's put a name there. So we want this to be a string. So I want to put reallocate with 12 bytes there. And then I put Elisa. Yes. So what I did here was that I want to uh print this. This is a string, right? And then we know the the syntax if you want to type out a string, right? Character, name, 12, and this, right? And then I'm going to have a return zero. So now you want to do a printf. So now how are we going to do this? Are we just going to write name like this and then continue? No, that's not the syntax for C. For C, you do this, your quotation, then we put something in there called a control. You put this, you can put a string there, and that string is called a control string. It's basically saying that I want to print this data type and take it from this variable. So the syntax is percentage sign, and then the type, so it's a character, so it's a string, so it's be s. That's the control string for a string. Control string for a string s. And then what's is taken it from? Taken from name. So you are saying you said put Elisa in name 12 bytes of memory. It's a character, a string of characters. I'm giving you 12 bytes of memory to store Elisa in it. So now you print it. You print the you now want to print it, right? So then this is a control string. So you're telling the compiler that and we're going to print a string, and then you're going to collect that string from name. Okay, hope that makes sense. Yeah. Yeah. So and then it prints out Elisa here. If you can see that, yeah, that's nice. So this is a control string. Okay. So I think we are good with a printf. How printing is done. So basically, yeah, you're going to print something in directly, a string directly, or a number directly, or um, you're going to store the string or that number in a variable. Use your control string, and then add your variable name to it. So it's like compilable fetch that string from this. So it's stored in memory. So I just want to try something out here. Okay. So we are not dealt with this topic yet. But we'll talk about it later. I just want to use it for like explanation. So let's say I do this. Maybe number equals 9. And I do this. Yeah. So we can see here, what I did was that we'll talk more about this. A pointer. This is the address operator. So I assigned a pointer to take the address. Don't worry if you don't understand anything. Just for explanation. You take the pointer and you assign it to an address, the address of number where it is stored in memory. And then I printed it over here. So you can see it printed the address of number. So this is where the compiler stored address at. And it stored it in this location, 00, and a lot of stuff. I think F is 15. So like if you can change all these zeros and ones, so it's just an address stored in memory. It's just a bunch of zeros and ones. So this number right now that we are seeing here, you know, it has been stored at this address location. So 9 is stored at this location. So you can this is the location of 9, but it is identified with number. Okay. And it's 4 bytes. Let me see whether I can do that. We'll do all of this. Okay. I just want to explain. So we can appreciate the language, right? As we continue to we try to appreciate the C language and how we are already dealing with memory addresses, uh, bytes and stuff like that. So what I want to print the size of uh yeah, so you can see here that it's 4, right? 4. So as I said earlier, that you are telling the compiler, so just by putting int here, you are telling the compiler that hey, give number 4 bytes of memory because I'm going to store an integer in there. So if I don't put that int there, the compiler doesn't know how much memory it should save. The compiler doesn't know how much memory it should save for number, and then you're not going to get a good result. You're going to have like code that crashes. So we can already see an example like appreciate C, right? And now we are thinking about you know memory and bytes and compiler. But for Python, you really just give any name to your identifier, then you just assign it to some string or some data type. Then you manipulate it, right? But then for C, you have to be more careful about these things. Right? You have to assign them the with their right data types. Okay. And then when we go more into data type, we go more into this. Uh, for a long data type, it's going to be assigned more space because we want to store like a very large number. So we are going to look at the range of numbers that can be stored for a long integer or for an integer, for a long integer as we progress. Yes. So I think that's it for print. This is our control string. This is uh your variable. It's like take this. We are going to put okay, so we are not done this yet, so okay, we'll do it that later. We'll do it that later. So the next thing, let's deal with one data. So I'm going to do the basic data input and output functions in today's class. And I think we'll end it there. So the next one is scanf. So scanf is okay. Let me explain. Scanf is so scanf is like is it's telling the compiler that the user will put will type something out. So be ready to receive it. Okay, so that's what scanning does. So it's going to scan the input stream. It's going to take whatever the user has put in and it's going to save it at some memory location. Does that make sense? So before we do that, when it's taking that, and it's going to save it. We need to allocate space for it, right? So let's start. We should be thinking that way, okay? So first we need to save it somewhere. So what is the first of all, what is the user going to put in? Okay, the user is going to put in a his name. So name is what? Name is a string. So they have to allocate some memory to string. Let's say let's allocate 4 bytes to string. So we've done that. I think compiler name. Let's give 12 bytes to name. It's a string. Good. And now we're going to do our print. Let's do a print f first. Let's do a print f first. And the print f is going to be what's your name. Leave some space there. Don't forget your semicolon. And then we're going to do the scanf first. So the scanf also has control string. So we're going to use a string is going to be S um and this and then name. So this is a syntax. Let me explain it. So I think I explained this one. So we're going to print this. This one we know about this already. Print this. Okay, don't forget your semicolon. And then so this is going to scan your input stream. It's going to scan it. It's going to go through your input stream. And it's going to fetch. It's going to fetch what? It's going to fetch a character. When it fetches that character, that string or that group of characters, it's going to save it in this variable name. It's going to save it at the address. That's why we added this. This is the address operator. Take note of it. This is the address operator. So it will take a bunch of strings, whatever strings the user inputs, and it's going to put it at the address of name. The address of name, like for example, this is an address, right, that the compiler allocated to a variable that we use, right? So now it's going to take those characters that are going to input you, the user. Then it's going to put it at this address. Okay. So let's run that. I don't know why I keep on deleting this part. Okay. Uh, so uh, let's hold direct. Yeah, so what's your name? So you can see the cursor blinking. Scan F signal to the compiler that the user will input something. The user will input something. So I'm going to input Elisa in there. So it saved it Elisa. I should have done a so let me add a printf here. So I'm going to do a printf. So that will print name so that you can see it. So your control string that will be the percent is comma name. Good, good. So you compile and then you run the machine code here. So Elisa, and then it prints Elisa from here. So what happened was that it scanned through the input stream. It took this, dumped it at the address of name, right? And then it printed this for me. So now let's let me try this. Let's try this. Let's try this. Right. Yes, I was expecting sometimes. Oh, okay. I'll check it out later. Okay. So Okay, so that's it for scanf and printf. Okay, so the other uh, another data input function is put, like this. Um, put character in there like this. Get, and then get character. Okay. So we have, what is that? This prints out a string. This prints out a character. This fetches a string. This fetches a character. So let's do that. I think because I'm using the command line command from that one. Okay, so let's maybe put a character. Maybe um so name equals gets, yeah, you can omit and talk.
Okay, um you see every time you just delete it and then do a new one. Is there a way you can like comment it out so that like we keep the code?
But are you like writing the code along with me?
Yeah.
Okay, okay. Then I'll do that. Okay, thank you. Yeah. So I allocated 12 bytes to name at at a memory location. So name, this is the syntax, right? So if we run this, so then you put the name. So, yeah. Okay. Search free arguments. I don't know why this is not correct. This an array. So it's supposed to be So you put in a character, then it's prints out the character. So this is like a short form of printf. This is a shorter form of scanf. I was so you can use this. Yeah, I was trying to get for a character. Okay, let me check it out. Okay, I think that probably. Let me. I hope that this would work. Okay, it will work. So for a string, so I allocated memory to. Okay, I defined um some space for a string like this, and then so the gets name would take the input from the user from the input stream, puts it into um this name variable, and then prints out that name variable to the output stream. So that's how gets work. That's how puts work, and that's how yeah. So for commenting is for multi-line comments, the forward slash and then the asterisk, and then at the end of the chunk of text that you want to comment out, put an asterisk and another forward slash. And for a single line comment, you just double forward slash and then um whatever, whatever, right? Okay, okay. Uh, so what happens here is that so for comments the compiler just passes them like they don't exist in the in your source code. It just passes over them. Yeah. Okay. So I think uh that is what we have for today. So let's just go over what we've done today. Help, can you hear me? Hello. If you can hear me, react. Okay. Yeah, let's see. Okay. Thank you. Yeah, so let's go over if anybody can. Okay, so let me open up for questions first. With what you've done today. So this is just the first class. We're going to improve over time. So if you have any way we can improve or how the teaching is going, you can bring it up. You can text me or you can, if you have any questions, you can ask. Yeah. So please, if you have any question, please ask. I want the class to be uh like a lot of we just go straight into doing the coding. So I get familiar with the syntax and stuff like that. And then you see, I even have to check for how they get work because it is a bit different from how they get character works. I thought it worked the same. I don't usually use get no, I use scanf and printf. Yeah. So I'm not familiar with the syntax. So the more you code, the more you get familiar with the syntax and these little things. And as you continue, I'm going to get a lot of errors for weird reasons. Someone's asking when they will be available. To be available soon when we can get it available. This that I have like questions. Uh, Kweku Sako, we ask a question.
Yeah, I think you answered it. The comments thing.
Or the recording.
No, I meant comments. Like I wanted to keep the code.
Ah, oh, this is just like we just started. You didn't like really good. I just wanted us to get familiar with like the syntax for some things. So we not really coded any solved any problem with C code. So when we solve a problem, and those are we will upload it to the Google Classroom. Okay. Yeah. Okay. Yeah. So the class will be around 1 hour 30 minutes. Yeah, the class. So with what we've done today, we just attach the operators. We have order of precedence for the operators. So we're going to put that the order of precedence for the operators. Which one comes before which, plus, minus, and the logical operators and the relational operators. You know about the how they work. We're going to put uh, a table of the order of precedence and then some examples for you to try and try and get them right. If you can't, or if you have any questions about this, we'll do it tomorrow in our next class. We'll talk about those ones. We will upload the order of precedence for the operators and uh, some functions in the standard input output header files and standard library header files. And then what you've learned today, basically, you just learned operators, naming your variables, variable types. Yeah. So next week we are going to start with tomorrow we are going to start with flow control. So that's our if statements, if else statements, switch keys, loops, for loops, while loops, yeah, conditional statements, stuff like that. Yeah, we'll do that flow control and conditional stuff tomorrow, God willing. Then we'll be done with I think the basics of C. Then we'll start next week. We start after we do the flow control, some assignments we put in the group. Then for you to try them. Then the next week we start going into solving some problems, and then going to deeper into stuff like types, memory allocation, preprocessors, and multi-files. So it's going to be fun. It's going to be fun. I don't know, the attendance was very low. The number of people that joined the group. People want to enjoy your vacation for longer. Oh, that's cool. But if you're able to engage in these classes, struggle to be going hopping from one YouTube tutorial to another YouTube tutorial, but you still don't understand it. So when we start this class, just get your laptop with you, beside you, get a small notebook. You just pen down some syntax, maybe some few things that you need to maybe note, which you'll be using as you code more and more, you just know it, and then you'll be coding along. So by the time you start next semester, you're already good to go for C programming. And it's like, I think C programming is 3 credit hours. So if you are good with it before you even start it, and you'll be good with it during the midterm and assignments and end of sem to get a very good A. Yeah, so I don't know, we encourage just I think averagely 9 people. Wow. Encourage like your friends to join the class. Yeah, so that they can join the live class, because they're recording, they can ask questions. And I love that you guys will ask more questions. So all of us will learn uh, and get good at C programming. Okay. I think I'll end here. See you guys tomorrow. Around uh tomorrow, meet around maybe 4:30. Yeah. Bye.